Okay, so I'm starting with this packet with number 20 because number 19 we're saving. So for number 20, this question is asking for increasing and decreasing. So that means you want to take the first derivative and set it equal to 0. And you can see that you're going to have a problem because you cannot take the square root of -4. Sorry about that. Okay, so that's impossible. So therefore, that just means that there's no critical points. So now that means that you can make a wiggle graph, and whatever number you try, you're going to get the same answer because it never changes if there's no critical point. So the easiest number for you to try is 0, and you get negative. And therefore, this function is always, sorry, I put that in the wrong thing, didn't I? Supposed to be putting it into, that's the first derivative. So I'm going to get 3 times 0 plus 12 equals 12, and it should be positive. You could try any number. If you did y prime of 3, you're still going to get a positive. So that means this function is always increasing, and that was choice C. Okay, for number 21, we're looking for critical points, so it's the same thing that we need to find the derivative and set it equal to 0. So this is going to be a product rule. So it's this times that. Okay, so it's going to be the first times the derivative of the second, which is a chain rule, plus the second times the derivative of the first, which is also a chain rule. Okay, so if you just simplify this a little bit, bring that 4 out to the front, and bring the 5 out to the front, you get that. And so there's no way they're going to expect for you to multiply this whole thing out, so hopefully you're going to recognize that there are things common to both terms. There's an x minus 3 here, and there's an x minus 3 here, and there is an x plus 2 here, and an x plus 2 here. So we're going to factor out an x plus 2 to the 4th, and we're going to factor out an x minus, there should be a 3 here, x minus 3 to the 3rd. So we're factoring those two things out, and now I'm left with this. So if we simplify the inside a bit, you get that. And if I simplify once more, I'll get this. And I'm setting that thing equal to 0. So when I do that, I should have 3 answers. X equals -2, x equals 3, and x equals 7/9. Okay, so the question is asking about the critical points. I don't know that they're critical points unless I put it into a wiggle graph. So here's my wiggle graph, and you're always going to put into the first derivative. So I'm going to have 3 values on there. And when you substitute values into the first derivative, you should get positive, positive, negative, and positive. So if you look at -2, you can see there was no sign change, therefore that's not a critical point. If you look at 7/9, there is a sign change, so therefore that's a critical point. And then if you look at 3, there was a change. So there's a critical point at x equals 7/9 and x equals 3. So that means that there's 2 of them, and the answer was B. Okay, here's number 22, and we're looking for points of inflection, so that's the second derivative. So I'm going to change the form first. And this is the first derivative. And then I'm going to find the second derivative. And then I'm going to take that second derivative, write it in a nicer form, and set it equal to 0. So I need to solve this, so I'm going to take the negative term and I'm going to bring it over there. And then I'm going to cross multiply. And then I'm going to set this equal to 0. And factor out a 6 and an x to the 4th. And now I'm going to solve. And I get x equals 0 and x equals 2. So I'm going to put those on a wiggle graph. And we're going to substitute into f double prime, the second derivative. So you should get these signs. And the question is asking for points of inflection. So if you look at over here, when x equals 0, you can see there's a sign change. And when you look at 2, you can see there's a sign change. So therefore there are points of inflection at x equals 0 and x equals 2. Okay, and so it would look like there's 2 answers, but that is actually wrong. Oh, I think I may have said that. The answer was C. Oh, no, okay. The question is saying at what value does it have a point of inflection? So you get x equals 0 and x equals 2. So how do you know which one to choose? Well, there's a big problem here, and that is x can never be 0, because if you go back to the original, if x was ever 0, it would be undefined. So x can never equal 0. So that means it has to happen when x equals 2, and that was choice C. Okay, and for number 23, we're looking for a maximum. So we're going to take the first derivative and set it equal to 0. So this is going to be a product rule. So it's the first times the derivative of the second plus the second times the derivative of the first, which is just 1. So I'm going to take that first derivative, simplify as I go. And I'm going to set that equal to 0. Okay, so you're going to need to factor this, and so you might notice that when let me just do another color. When I did this part over here and I simplified, actually I shouldn't have done that, because there's an x minus 3 here and an x minus 3 here. So I'm actually going to go back. I just did that because I wanted you to see that I think that's what most of you would do, and sometimes you got to go back. So I'm going to keep, this is what I originally had. Okay, and then hopefully you can see that both of these terms has an x minus 3 in it. So I'm going to factor out an x minus 3. And that's going to leave me with a 2 and an x minus 2 and an x minus 3. Okay, so now I'm going to simplify a little bit. 2x minus 4. And I'm going to simplify one more time. So 2x and 1x is 3x, and a negative 4 and a negative 3 is negative 7. And now I'll get two solutions, x equals 3 and x equals 7 over 3. So we're trying to find out when there are maxes, so I'm going to make a wiggle graph. And remember, maxes and mins always come from the first derivative. So I'm going to put values into the first derivative, and you should get a positive, negative, positive. So if you look at this first one at x equals 7/3, the function was increasing and then decreasing, so there has to be a max. For x equals 3, the function was decreasing and then it was increasing, so there has to be a min. So the question was asking what value has a relative max, and it's going to be right here when x equals 7 over 3, and therefore the answer was D. Okay, that finishes that sheet.